Intersection side distance. After completing this lesson, the student will be able to appreciate the need for providing intersection side distance, why it is required to provide intersection side distance, understand the concept of side triangle and important consideration for intersection side distance. Also, the student will be able to identify different types of intersection control that affect required intersection side distance. These are the considerations from AASHTO, American Association of State Highways and Transport Officials, and also understand the basis for estimating required intersection side distance for two types of intersection control. There are several types of intersection control as recommended by AASHTO. In today's lesson, we shall cover two types of intersection control and accordingly try to understand the basis for obtaining intersection side distance for those two types of intersection control. First of all, intersection side distance, why it is important. Basically, inadequate side distance is a major contributing factors to a large percentage of intersection crashes. Directly, it affects the safety. So, therefore, adequate intersection side distances should be provided for smooth, efficient and safe operation of traffic at intersections. One should remember that intersection side distance is more critical than open roadways because drivers are frequently distracted from maintaining a continuous view of the upcoming roadway. Therefore, intersection side distance becomes more crucial. Side distance which are considered safe directly depend on vehicle speed, always it depends on the vehicle speed and to the resultant distances traversed during perception reaction time and braking. We have already discussed the side distance consideration, particularly say stopping side distance. So, we know there is a perception reaction component and then there is a braking component, and obviously the required side distance depends on the vehicle speed. So, vehicle speed as well as the time for perception reaction as well as for braking or other kind of activities. Let us now try to understand the concept of side triangle. Side triangle is specified areas along intersection approach legs and across their corners, included corners, which should be clear of obstructions that might block a driver's view of potentially conflicting vehicles. That means, when vehicle is approaching an intersection, it is basically that triangular area near the corner which should be free from all kinds of obstructions that might block the view or the sight, line of sight. And dimensions of side triangle depends predominantly on two major considerations. One is the design speeds of intersecting roadways. Maybe there is a major road and there is another minor road. Therefore, the required side distance will depend on the design speeds of both roadways, and it also depends on the type of control what is used in that intersection. It is very, very important to understand this type of control, because they actually mean different legal implications in terms of the behavior of drivers, what they are supposed to do as per the given type of control in the intersection. So, therefore, the requirement in terms of side distances depends predominantly on design speed of both roadways as well as the type of intersection control what is used at particular site or intersections. Then there are two types of side triangle. We have understood the concept of side triangle now, but there are two types of side triangle. One is approach side triangle and the other one is called departure side triangles. Now, let us try to understand what is approach side triangle and then what is departure side triangles. Approach side triangle as given here is the triangular area free of obstruction that might block an approaching driver's view of potentially conflicting vehicles. I would like to draw your attention on this particular aspect, an approaching driver's view. That means, when a vehicle is approaching, the vehicle is in motion, that time what is the triangular area that should be free from obstruction for the approaching vehicle. Now, length of legs should be such that drivers can see any potentially conflicting vehicles in sufficient time to slow or stop before colliding with another vehicle within intersection area. That means, when a vehicle is approaching, it is not stopped vehicle, it is a vehicle in motion. That time, if it finds another conflicting vehicle, then either it should be able to slow down the speed or it should be able to stop. So, the required side distance or triangular area free from obstruction should be adequate enough either to change the speed or to stop before colliding with another vehicle within intersection area. Another crucial point what we must understand in this concept, in this context, is the concept of decision point. So, decision point is the location at which the minor road driver should begin to brake to a stop if another vehicle is present on an intersecting approach. That means, it is the point from which the vehicle, if it finds another conflicting vehicle, then the first vehicle should be able to stop at a safe distance without colliding with another vehicle within the intersection area. Look at the sketch now, where the concept of approach side triangles is explained. there is a major road which is shown here. It is a major road. This is the major road, okay, and this is another minor road. Now, a vehicle which is approaching from the minor road, that means the vehicle is coming from this direction. Now, say it has to take left turn or maybe right turn or maybe it is going straight. So, let us follow the AASHTO convention or US convention, that means driving is like this as shown here. Okay. So, when this vehicle is trying to enter into this area, it is possible that a vehicle may come from the left side. So, there is a vehicle which may come from this end or from this side. So, this vehicle or the approaching vehicle should not collide with another vehicle. So, this is the shaded area what should be free from obstruction, considering a vehicle from the left. Similarly, if we consider the other condition, an approaching vehicle trying to enter or trying to cross or maybe trying to take left turn or crossing the intersection, a vehicle may come from the right side. Okay. So, again this vehicle, approaching vehicle, should not collide with the vehicle which is coming from the right side. So, that means this portion of the area should be free from obstructions, so that the operation or the movement of vehicles in the intersection could be safe. So, this is the concept of departure side triangles. So, we have two triangles, one considering the traffic coming from the left side and another considering the traffic from the right side. Now, departure side triangle. Departure side triangle provide side distances sufficient for a stopped driver on a minor road approach to depart from intersection and enter or cross the major road. The basic difference between approach side triangle and departure side triangle is, in departure side triangle we are considering a stopped vehicle. That means a vehicle is stopped and then it wants to either take left turn or right turn or maybe it wants to cross that major road. Okay. So, under this condition, for a stopped vehicle to accelerate, speed up and then cross the intersection, what is the required intersection or the side triangles that we are calling as departure side triangles. So, understand this part clearly. Provide side distance sufficient for a stopped driver on a minor road approach to depart from intersection and enter or cross the major road. Now, departure side triangles should be provided in each quadrant of each intersection approach controlled by generally stop sign, because wherever there is a stop, a vehicle has to stop and then start the movement either to cross or to take left turn or to take right turn. For yield control intersections also, vehicles may be required to stop before they cross the road or take left turn or right turns. Now, it also should be provided, that means departure side triangle should also be provided for some signalized approaches wherever it is necessary. We shall come back to this point later. Now, look at this sketch. The concept of departure side triangle is explained here. It is similar to the concept of approach side triangle, except the vehicle is a stopped vehicle from the minor road. Therefore, normally the required area, triangular area or the side triangle dimension may be different. But in this case also, as say a vehicle, a driver or a vehicle is coming from the minor road, this is the minor road and this is the major road. So, when a vehicle from the minor road is trying to enter into this major road from stopped position, then a vehicle may come from the left side. It is also possible that a vehicle may come from the right side. So, required side triangle is there, or it is the required side triangle considering the traffic from the left, and this is the required side triangle considering the traffic from the right side. So, therefore, we are showing here the clear side triangle for viewing traffic from left, and this one is the clear side triangle for viewing traffic from the right hand side. So, remember that the movement we are considering like this and like this. Okay? This is different from whatever is followed normally in India, but predominantly this concept is used in AASHTO. So, we are using the same convention what is followed in AASHTO manual, but the concept can be applied in the similar manner for Indian operating condition. The only difference will be whatever we are defining as left turning, that would be actually right turning for Indian condition, and whatever we are defining as right turn, that will be actually left turn in Indian condition. That is the small difference one should keep in mind. Now, obstructions within side triangle. We know that side triangles should be free from all types of obstruction for safe and efficient movement of traffic in intersection area. Now, while looking at the obstructions within side triangle, one must consider both horizontal and vertical alignments of both roadways. That means, we should consider the horizontal as well as vertical alignments, because line of sight might be blocked due to all these factors. It is also necessary, like for every other types of side distance, it is necessary to specify the height of driver's eye above road level and also the height of object. In this case, both are actually vehicles. One vehicle is approaching or trying to cross, trying to take left turn, and that vehicle should not collide with another vehicle which is coming from other direction, okay, along the say major road. So, therefore, height of driver's eye above road level and height of object above road level, both are to be specified. In AASHTO, both are taken as 1.08 meter, because both are actually vehicles. It was the same distance, or it is the same distance which was used earlier when we discussed about passing side distance and the design considerations and provisions in terms of AASHTO recommendations. What could be the nature of obstructions? It could be buildings, fences, walls, it could be parked vehicles, trees, or sometimes even the terrain itself. The terrain profile could be such that it will cause obstruction to the line of sight. Now, intersection control types. Recommended dimensions of the side triangles vary with the traffic control used. I have mentioned this point even earlier also. The required side distance very much depends on the type of control used for the intersection. Why it is so? Because different types of control means different legal constraints on driver in terms of their behavior. So, different legal constraints on driver in terms of their behavior. So, obviously, the requirement in terms of side distance also will be different. AASHTO considers 6 different types of intersection control. Case A, intersection with no control. Case B, intersections with stop control, where traffic on minor roadway must stop prior to entering the major road. Now, there are other 4 types. Case C, intersections with yield control, where vehicles on the minor intersecting roadway must yield to vehicles on the major roadway. It may not stop, the vehicle from the minor road may not stop, but it must yield to vehicles on the major roadway. Case D, intersections with traffic signal control. Case E, intersections with all way stop control, and case F is stopped vehicle turning left from a major roadway. One must notice this part, from a major roadway. That means a vehicle which is stopped and trying to take left turn following US convention of driving and trying to enter minor roadway, where left turning must yield to opposing traffic again on the major roadway. That means, it should be able to take right turn and it must yield to opposing traffic on the major roadway. So, under this control condition, what should be the requirement for side distance and what should be dimensions of side triangle, that we shall discuss under case F. So, these are the 6 major control types or the type of control which is considered in AASHTO manual. In today's lesson, we shall discuss about the first 2 types of intersection control and try to understand the basis for obtaining the side triangle dimensions. Case A, no control, or what we say uncontrolled intersection. In this case, intersections are not controlled by yield signs, stop signs or traffic signal. Therefore, drivers of a vehicle approaching an intersection of this type must be able to see potentially conflicting vehicles in sufficient time to stop before reaching the intersection. So, in no control intersection, vehicles are free to approach intersection area, but when a vehicle is approaching an intersection area, it must be able to see potentially conflicting vehicles on other roads at sufficient safety margin, so that the vehicle, if necessary, should be able to stop before colliding with another vehicles within intersection area. Now, you can understand clearly this is a case where approach side triangles should be considered, because vehicle is in motion, vehicle is not bound to stop under normal condition. It will stop only if it is necessary and if there is another potentially conflicting vehicle on the other road. Therefore, in this case approach side triangles should be considered. Normally, no departure side triangles is needed, as these intersections typically have very low traffic volumes. Yes, a vehicle, say from a minor road or even from the major road also, let us consider a vehicle from the minor road. Suppose it is stopped because there is a vehicle which potentially conflicting vehicle which was coming along the other road. But because such intersections as very low volume intersections, it is unlikely that once the vehicle is stopped, then before it crosses or before it takes turn, it is unlikely that another vehicle or another potentially conflicting vehicle will reach there. It is quite unlikely, particularly because these are very low traffic volume intersections. So, therefore, it is not necessary to consider the requirements in terms of departure side triangle. Now, what should be the basis for location of decision points or trying to understand or trying to calculate the dimensions of approach side triangles? The basis is very similar to what we discussed for stopping side distance, again as per AASHTO approach. Why? Because only thing, under emergency condition, vehicles should be able to stop before entering and colliding with another vehicle within the intersection area. Therefore, the basic approach or basic consideration for calculation of distance is very similar to what was used earlier for stopping side distance, but I repeat, but with a slightly different assumptions. Why? Let us try to understand that part. Now, here also there are two components. One is the perception reaction time as it was there for stopping side distance, and then another component is the braking component. When the brake is applied, then whatever distance is required by the vehicle before it stops. Now, the first part, detection and recognition of a vehicle that is substantial distance away on an intersecting approach and is near limits of the driver's peripheral vision may take up to 2.5 seconds. This is observed or this is found from field observations. In some cases, it might be even shorter time, lesser than 2.5 seconds, but it may take up to 2.5 seconds. So, actual braking, if necessary, it starts after 2.5 seconds. It may start up to after 2.5 seconds. Then how one can calculate the stopping distance? That means distance to brake to a stop, that can be determined as it was determined for the case of stopping side distance. Now, here one must remember some very important considerations what make it different from the calculation what was used in stopping side distance. Now, vehicles reduce speed to approximately 50% of their mid block running speed even when no potentially conflicting vehicles are present. That means, whenever any vehicle is approaching an uncontrolled intersection or an intersection with no control, it is observed from field that vehicles or drivers normally reduce their speed up to about 50% of the speed, running speed or the mid block, more specifically mid block running speed. Now, this they do even when there is no conflicting vehicle, solely because of the nature of the control, because drivers are aware that they are approaching an uncontrolled intersection. Now, braking at greater deceleration rate as assumed in stopping side distance, it was assumed as 3.4 meter per second square, that can begin up to 2.5 seconds after a vehicle on the intersection approach comes into view. That means, even if there is no conflicting vehicle, still the vehicle speed is reduced and drivers apply deceleration rate up to 1.5 meter per second square, which is a lesser deceleration rate as compared to what was assumed for calculation of braking distance in stopping side distance consideration. So, altogether what is happening when vehicles are approaching an intersection with no control, vehicle speed is reduced substantially up to 50% and the perception reaction component and the braking component both are happening with a lesser speed than what was the average running speed in mid block condition. So, altogether distance travelled by an approaching vehicle, the distance travelled means during the perception reaction as well as braking is lesser as compared to the distance travelled by vehicles when we consider stopping side distance. Therefore, these values are normally lesser than the values for stopping side distance. Now, based on field observations, AASHTO has suggested different length of leg, making it as a function of the design speed. All those considerations are there. Vehicle decelerate up to 1.5 meter per second square, drivers reduce speed approximately up to 50% of the mid block running speed. They may take up to 2.5 seconds in the perception reaction component, and if necessary then they apply brake. Considering all these things, AASHTO has given design values for the length of leg, making it as a function of the design speed. Say for example, the distance of side triangle may be determined based on design speed for two roads. Say if the design speed is 100 kilometer, then AASHTO says the required length is 105 meter. So, accordingly for each approach, if we know the design speed, accordingly from the table we can get what is the required length. But to us it is important to understand the basis for these design values, which I have explained. Now, clear triangular area will permit the vehicles on either road to stop if necessary. So, this should be provided on each approach when the intersection is uncontrolled or intersection with no control. Now, if the design speed is known, one can use the design speed and accordingly take the value. If the design speed is not known, then 85th percentile of mid block running speeds can be taken as representative design speed, and accordingly the length of the triangle or the dimensions of the triangle may be decided. some more considerations, some more points we must understand. Where the approach grade along intersection approach exceeds 3%, it is necessary to apply appropriate adjustment factor. That means, whatever values are given in ASTO table, those values are essentially for approach grade plus minus 3%. That means, upgrade or downgrade. But if the grade is different or outside this range, then suitable correction factors are to be applied. Those factors are also given in ASTO manual. Say for minus 6 to minus 3% approach grade, correction factors vary from 1 to 1.2 depending on actual grade and actual design speed. As I indicated, from minus 3 to plus 3, no correction factors is required, and from plus 3 to plus 6 percentage grade, the correction factors recommended are 0.9 to 1. Again, actual value will depend on grade and the design speed. Finally, if side distances adjusted for grade cannot be provided, then one must explore the possibility of installing regulatory speed sign or even stop sign to make the operations of traffic in the intersection area safe. Now, case B, stop control on minor road. Here, traffic on minor road is controlled by stop sign. Traffic on minor road is controlled by stop sign, and obviously, because we are looking at the requirements of a stopped vehicle, that means a stopped vehicle to accelerate and complete the turn, either left turn, right turn or crossing, what is the requirement. So, it is a case for departure side triangles, and there are 3 sub cases as shown here in this case. So, maybe this is the minor road, a vehicle is coming from the minor road, it may take a left turn, it may take a right turn, or it may even cross the major road. So, there are 3 types of movements. So, there are 3 different sub cases: making a left turn, making a right turn and crossing the road. Let us see the requirement in terms of side distance for each possible condition. Case B1, left turn from minor road. Now, here departure side triangles for traffic approaching from either the right or the left are applicable. So, here again let us see the sketch. Here this is the vehicle. So, when this vehicle, stopped vehicle, is trying to do the maneuver, it is possible that a vehicle may approach from the left side. So, this is the triangular area which should be free from obstruction. It is also possible that when this vehicle is trying to move, a vehicle may come from the right side. So, again this area should be free from obstructions, and location of the decision point on the minor road should be decided now. So, there are 2 cases, a vehicle, considering a vehicle from the left side, which is this case, and the other case is a vehicle from the right side. So, this is that case. Okay. Now, location of decision point on the minor road, as per ASTO, it is 4.4 meter from the edge of major road travelled way. That means, essentially this is the distance what we are calling as 4.4 meter, okay, from the edge of the travelled way. Now, how this 4.4 meter is taken? Let us again try to understand the basis. front of vehicle from the edge of the major road, it is found say 2 meter. So, we have taken this complete thing as 4 meter. Now, this complete thing is 4.4 meter, which includes front of vehicle from the edge of the major road as say 2 meter and distance from the front of vehicle to driver's eye, because driver is sitting at a distance from the front of the vehicle. So, that normally in American condition it is 2.4 meter. So, altogether this distance become 4.4 meter. So, what should be the length of side triangle along the minor road if we consider a 2-lane major road? Now, in this case it is 4.4 meter plus half of the lane width, because if it is a 2-lane major road, if we consider, then 1 lane for each direction. So, it is half of the lane width which should be added to this distance 4.4. In this case it is 4.4 plus 1.5 lane. Okay. So, that way we can calculate the dimension of this side triangle. Now, let us see how we calculate this length, this dimension, okay, the other along the major road. Now, along the major road, the distance is calculated in this fashion: 0.278 V major into Tg. Now, V major is the design speed for the major road and Tg is the time gap for minor road vehicle to enter major road. That means, the vehicle is stopped. So, how much time it will take for the vehicle to accelerate from stopped position and complete the turn, either complete the turn. Now, this time 0.27 is the multiplying factor, because we are considering or taking the design speed in kilometer per hour. So, this is the conversion factor. Now, this Tg, what should be the value? This Tg value depends on type of design vehicle. That means, if the stopped vehicle is actually a car, the time requirement will be different as compared to a condition where the design vehicle is a commercial vehicle. So, it depends on the design vehicle or the type of vehicle, and the values what are recommended in AASHTO, they are actually obtained from field observations, and it is found that this time gap varies from 7.5 seconds to 11.5 seconds depending on design vehicle. Say for car it is 7.5, for other commercial and heavier vehicles it is even more. And this value 7.5 seconds to 11.5 seconds as recommended in AASHTO based on 2-lane highway with no median and minor road grade 3% or less. That means, this time gap is for 2-lane highway with no median and minor road grade 3% or less. Now, if this value is used, say for car where if we use 7.5 seconds, then AASHTO recommends that under this condition most major road driver need not reduce speed to less than 70% of their initial speed, because it is found from field observations that vehicles which are travelling along major road, they also normally they reduce the speed as compared to the speed in the mid block condition. But if we use this time gap as 7.5 seconds to 11.5 seconds depending on the vehicle type and other thing, then vehicles on the major road, they will normally not require to reduce speed up to less than 70% of their initial speed. Okay. Now, for multi-lane highways, 0.5 seconds to be added for car for each additional lane from the left in excess of 1, from the left in excess of 1, that should be noted carefully, to be crossed by the turning vehicle. That means, what we told 7.5 to 11.5, these are for 2 lane roads. So, for multi-lane highways, some corrections are to be applied. How much additional time to be added, that will depend on the vehicle type. Say for car here, it is 0.5 second. For commercial vehicle, the value is different. Now, this should be added, 0.5 seconds should be added for each additional lane from the left in excess of 1 to be crossed by the turning vehicle. So, for 4 lane undivided road, vehicle has to cross two lanes from the left instead of 1. So, it is not 7.5, rather 0.5 into 2. So, 1 more second to be added. If the minor road approach grade is an upgrade that exceeds 3%, up to 3% there is no corrections, it is still 7.5 to 11.5, but if it exceeds 3%, then 0.2 seconds may be added for each percentage grade for left turn. And for divided highways, it is necessary to consider multiple design vehicles and median width, because it will vary substantially depending on the what is the exact median width, whether it can store a vehicle, that means it will also depend indirectly on the type of design vehicle. So, there are appropriate considerations for all these conditions, considering the effect of median width and different design vehicles. Now, case B2, right turn from minor road. Here also the departure side triangle for traffic approaching from the left should be considered, because the traffic is taking right turn. Here also the length of leg of side triangle along the major road is calculated using a similar formula as what was used for left turn, but in this case the time gap Tg for minor road vehicle to enter major road is slightly different. It is observed that vehicles normally accept for right turn, vehicle accepts a slightly lesser time gap. Astro says that one can consider 1 second lesser time as compared to what is recommended for left turn. So, left turn it was 7.5 to 11.5, here it is 6.5 seconds to 10.5 seconds, but these values again depend on the type of vehicle, whether it is a car. For car it should be 6.5, for commercial vehicles, heavy vehicles, it should be more, and this is the value which is applicable for 2 lane highway with no median and minor road grade 3% or lesser. So, in this case also, if the minor road approach grade is exceeds 3%, then Astro recommends that 0.1 seconds may be added for each percentage grade for right turns. Now, if required side distance for a right turn maneuver cannot be provided, even considering this reduction in time by 1 second, then in that case one should explore the possibility of installing regulatory speed sign or other types of traffic control devices on the major road approach, okay, so that the speed can be regulated on the major road. Now, the case B3, crossing the minor road. Normally, the departure side triangles for left and right turns onto major road provide more than adequate side distance for minor road vehicle to cross the major road. Therefore, normally no separate consideration is required, but there are certain special situations like when left or right turns are not allowed and crossing is the only legal operation, or when number of lanes to be crossed are more than 6, or when substantial amount of heavy vehicles cross the highway and steep grades are present. Those are the special cases where one has to look for the required side distance for crossing the minor road. In normal condition, the time gap varies from 6.5 seconds to 10.5 seconds, as it was used for case B2, that means for right turn. Same consideration here, but for crossing a major road with more than 2 lanes at 0.5 seconds per car, the value is different for commercial vehicles for each additional lanes to be crossed and for narrow medians that cannot store the design vehicles. Similarly, a similar correction is applied for the grade if the grade is more than 3%. Now, we have discussed two types of intersection control and tried to understand the basis. A few questions from the discussion: explain the concept of approach side triangles and departure side triangles. Number 2, mention different types of intersection control considered by ASTO for the estimation of intersection side distance. Third question: for an intersection with stop control, you can consider it is a 4-legged intersection on minor roads, stop control on minor road, what should be the dimensions of side triangle considering left turn from the minor roads under the following condition, where the design vehicle is a car, design speed of the major road is 100 km per hour, major road is a 4-lane undivided roadway, and minor road approach is located on a 4% upgrade. So, under these condition, what should be the dimension of side triangle? Now, I shall try to answer the questions of lesson 3.4. Why it is necessary to provide overtaking side distance? You know that every vehicle do not travel in the same speed, particularly in mixed traffic operation. So, therefore, wherever there are traffic operation on highways and other types of roads, particularly for mixed traffic operation, in other cases also it is required, but it is more required for mixed traffic operations due to the differential speed criteria. So, opportunity for overtaking should be given. Also, restriction for passing opportunities affect the level of service for highway, particularly 2-lane two-way roads, as the measure of effectiveness used are percentage time spent following and average travel speed. So, if adequate overtaking side distance or overtaking side opportunities are not provided, then both these MOEs would be affected and level of service will be degraded. When one should recommend intermediate side distance, that means sections where providing overtaking or passing side distance is impractical for reasons of economic and otherwise, then it is a consideration by Indian Roads Congress. IRC says that provide double of stopping side distance, which is nothing but the intersection side distance, because it will give limited opportunity for overtaking. Explain the term headlight side distance. Particularly in valley curve during night travel, it is only the length of the road which is visible by the illumination of headlight, that portion is visible to driver. So, particularly for valley curve, it is crucial, and therefore, that distance should be adequate for emergency stopping of vehicle, and we consider the distance as headlight side distance. That means, the distance which is visible by the illumination of headlight. In the basis for ASTO recommendations about overtaking side distance. Now, look at this sketch. ASTO considers 3 vehicles: vehicle A which is trying to overtake, vehicle B which is the overtaken vehicle, different positions of overtaken vehicle, and vehicle C, which is the vehicle coming from the opposite direction. Now, there are four components which are considered. D1 is the distance travelled by overtaking vehicle during the initial perception reaction and acceleration up to the encroachment of opposing lane. So, you can see vehicle position here, it is just trying to encroach the opposing lane. So, this distance is D1. D2, this is this component, the distance travelled during the actual overtaking. So, vehicle A from this position, it goes to the opposing lane, complete the overtaking operation, and then comes back to its original lane, earlier lane. So, this distance travelled is normally taken as D2. D3 is the safety margin, the clearance between the overtaking vehicle and the vehicle from opposite direction after overtaking vehicle has completed the overtaking maneuver. So, that this is the overtaking vehicle which has just completed the overtaking operation, and then at the same time the opposing vehicle is in this position. So, this time gap is taken as D3, and D4 is the distance travelled by opposing vehicle during this overtaking maneuver. Now, how to calculate these distances? There are provisions in AASHTO. Now, D1 can be calculated with the help of this formulation 0.278T1 into V minus M plus AT1 by 2. We have explained, we have discussed this basis for this equation. Now, for different speed ranges, the values of A, that is the average acceleration, and the value of T, that is the time for initial maneuver, they are decided. So, depending on the speed range, the values can be selected from manual. Similarly, D2, the basis we have discussed, there are different speed ranges. So, one can decide this value of T2. Discuss this value of D2. Now, equation is same, but T2 value is obtained experimentally and reported in manual. Then calculation of D3, which is the clearance, again depend on the speed range. For different speed range, these D3 values are given, so suitable values can be taken. For D4, it is taken as 2/3 of D2. Why 2/3? Because up to certain position, the overtaking vehicle can really cancel the overtaking operation and it can go back to its original lane. So, while calculating the distance covered by opposing vehicle, it is not necessary to take complete D2 length, but it can be taken as 2/3 of D2. Now, all this D1, D2, D3 and D4, they are based on the average passing speed of vehicles. So, therefore, it is necessary to calculate or to establish a likely and logical relation between average passing speed and highway design speed, because highway design speed is known. So, therefore, a logical relationship to be established. If this is the design speed, then what should be the average passing speed? Then only D1, D2, D3, D4 components can be calculated and they can be added together. Now, the speed of passed vehicle or overtaken vehicle is taken as average running speed at a traffic volume near capacity. So, speed will be reduced, traffic stream speed will be reduced once the volume is more. Now, when the road is operating at its capacity level, that means volume is near capacity, then what should be the stream speed? Actual past vehicle speed is assumed same as the traffic stream speed when the volume is at or near capacity. So, that gives a basis for obtaining the speed of overtaken or passed vehicle. Then the speed of passing vehicle is assumed 15 km per hour greater. So, whatever will be the speed for passed vehicle, passing vehicle speed is assumed 15 km per hour greater. So, this speed is known now. Once this speed is known, passing vehicle speed is known, average speed is known, then D1, D2, D3, D4 components can be calculated. They may be added together to get the required overtaking side distance. Thank you.